So this session we will be seeing what is the properties of U-shaped curve, otherwise called as eh? normal probability curve, Gaussian curve, because of the discoverer Gauss. Gauss discovered this, therefore this is called as Gaussian curve, normal probability curve. And just since the shape is U, we call it as U-shaped curve. So it's never touches the x-axis. Therefore, we call this as asymptotic. This side also, the other side also. So these are the things which we are going to see: definition, shape, properties, effect of mean and standard deviation on the shape of normal probability curve, assumption of normality, skewness, and kurtosis. That's what we are going to see. So normal distribution here, bell-shaped curve or U-shaped curve, which is symmetrical from here, the left hand side and right hand side equally placed. 50% of the data lies on the left hand side and another 50% on the right hand side. And center we have three statistics coinciding. So we call this as data statistics. This is statistic calculation also. So mean is equal to median is equal to mode. So all these things we know. So discovered by Gauss and hence the name Gaussian curve. Laplace also discovered this independently in those days. Two people discovered. Since we do not have communication in those days, Laplace also discovered this. So it is a theoretical. So normally we never achieve this curve, but anyway, it's a theoretical ideal distribution. Real life never match, but it may near the normal probability curve. So it may approximate the normal distribution, and we say those things are normally distributed. And based on that, we go for differential statistics. 50% of data on the left and another 50% on the right. At center, we have mean equal to median equal to mode, all the three. Since one mode is there, we call it as unimodal. And asymptotic curve never touches the axis. Nu equal to mean and sigma is equal to standard. Normally, it refers population mean and population standard deviation. Generally, many times we may not calculate this. We take a sample and do it. Mean gives the location of the line of the symmetry. So this location is given by the mean. If mean changes, this also will be changed. This line also will be changed. And standard deviation gives the spread of the data. As we have said, the curve spread from -3 standard deviation to +3 standard deviation we have, and therefore this is said as 6 sigma difference. The left side you have 3 sigma distance from the mean, and right side we have 3 sigma distance above the mean. Totally we have 6 sigma distance, and hence in management we tell 6 sigma performance. 6 sigma performance means 100%. We may not achieve, but generally we will tell we have to perform 6 sigma performance, which means that we have to perform better. So you say this, so this is the nu, whose value is 10, and the next value is 11, and the other mean value is population mean value is 12. You see the curve shifts from left to right. So if mean changes, the normal body shifts on the x-axis. It moves on the x-axis. So the next one, if sigma increases, the spread of NPC increases. As we have seen, the value of sigma. Here the standard deviation is true for the green curve. So you can see the center point is the mean. After that we will be having plus sigma 1 distance. This one is plus sigma 1 distance, 1 standard deviation. This is 2, hence the curve is like this. If standard deviation is 3, it is spread little more, that pink color. If standard deviation is 4, you can see mean plus 1 standard deviation will be here. Therefore, that so the standard deviation tells the spreadness. As standard deviation increases, curve is more spread. If it decreases, curve is little spread. So we have one example. Which curve has a greater mean? Curve A. What is the mean? 15. Curve B has 9 roughly. Which normal curve has a greater standard deviation? B. So A standard deviation will be around maybe 1. B standard deviation will be around maybe 2 or 3. So we have the answer here. Just these are some few data we are presenting, and we correlate with NPC, normal probability curve. So median is 6, mean is 7.1, mode is 0. We don't have a mode. Standard deviation 6.8 and range 24. Whether this data fit for normal probability curve? This does not fit. So still we go further. Median 5, mean 5.4, mode none. Whether does this data fit for NPC? This also it is getting near, but it is not fitting. The data is law of manuscript writing. So this is exercise hours per week. We have median 3, mean 3.4 on mode 3, standard deviation 2.5 and range 12. Does this approximately it nears the standard deviation? Still the next data we have wake up time in the morning. I think it is not us. So median 7, so mean 7, maybe 7 p.m. in the morning, 7 a.m. in the morning, mean 7.04, mode 7. So this is almost, it is in normal probability curve as the data goes. So if you could see, if you draw, you can draw like this. So what does this different graph says? As the number of sample increases, the normality is getting approached. Therefore, we have to take more sample. If you take more sample, then our data will be better. Generally, more than roughly 500 or 300. That's what we say in survey studies. We have got up to 600. It will be better always. In experimental, it can be 50. Survey means you have to go to 500, 600. Then our data will be better. If not, data is not better. Calculation will be not that much powerful. So we have seen this. So these are the percentage of cases lying between the two, -1 standard deviation to +1 standard deviation. We have 68.26% of cases, and -2 standard deviation to +2 we have 95% of the cases, or 95% of the data lies between -2 standard deviation to +2 standard deviation, and 99.72% of the data lies between -3 standard deviation to +3 standard deviation. This is how while we go for differences, we use all these things. So as you can see, so this is the first option is 0 to Z. So 0 is the mean value, and if you go, it will show 0 to Z. The second option is it takes from the left, up to Z. So wherever you place the icon, it will show what is the percentage, and it is Z onwards. So this is from a website called Maxisfun. See after the class. So skewness, data can be positively skewed or negatively skewed. Otherwise, right skew or left skew. So if you see positively skewed, the skewness is on the right hand side of the NPC. So positively skewed. If the skewness is on the left hand side of the NPC, which is negatively skewed. And sometimes the plateau can be high or it can be less. If it is high, it's called leptokurtic, and if it is low, it is called platykurtic. If there is a skewness and kurtosis, then it may not follow NPC. We see the values. So again, the same example. There is no skewness here, no kurtosis here. This is positively. This is left skew. These are again examples. You can see the mode. The mode is more than the mean in a left side skew. Here, the mean is more than the mode in right skew. Those three lines are mean, median, and mode. So just what we said, positive skewness, mean is more than mode, negative skewness, mean in less than mode. So these are the calculations. We can calculate manually. Skewness is equal to 3 into mean minus median by standard deviation. The otherwise, P percentile 90 plus percentile 10 divided by 2 minus P50. Similarly, we can calculate kurtosis manually. Kurtosis is equal to Q divided by percentile 90 minus percentile 10, where Q is quartile deviation. So this can be done manually also through statistical software. So when mean is more than median, so we have positive, less than median we have negative, equal that is normal. So these are the values. Greater than 0.263 it is lepto, lesser than 0.263 platykurtic. These are the norms for skewness and kurtosis. And this is the original normal probability distribution for intelligence among populations of US. This has been calculated and I taken it from the net. So the IQ distribution, intelligence scores. So the mean is 100. The mean is 100 and the standard deviation is 15. Okay, based on this, they have categorized people. So this is a true data. Again, you can see if more than 160 they are genius, and only 2 people they have Mozart and Einstein, they have got IQ score as 160. And these are high performing people, and here normal performing people are less than below normal, and these will be having idiots or morons, all those things on the left hand side. So this is an example, but it is calculated with a mean of 100 and a standard deviation of 50. So now we are calculating these things, skewness and kurtosis. We are going to calculate, and we are going to see whether our data goes by a normal probability distribution by Shapiro-Wilk test, and also histogram we are going to see, and QQ plus we are going to see. So I'll show this, and also later I will demonstrate. So skewness, if our Z values lies between minus 1.96 to plus 1.96, then it's better. It goes via normal probability curve. How to calculate Z value? Z value is equal to our statistic. This skewness this value, the value which we are calculating, divided by standard error. That value is this. This I will show after this PowerPoint presentation, and you see it is minus 11.14. Therefore, the data which we have taken is not following normal probability curve because it is not lying within this values. Minus 1.962 plus, because it covers that 95% of that will be covering within this. So therefore, our taken data does not follow normal probability curve. Again, the same thing for kurtosis. The same Z values, it should be between minus 1.96 to plus 1.96. Statistics divided by standard error. This is the statistics and standard error which we are going to calculate now. So the value is 9.7. 9.7 does not belongs to this. Therefore, our data does not follows normal probability curve. This, just for an example, set of max scores has a mean of 70 and a standard deviation of 8. A set of English test score has a mean of 74 and a standard deviation of 16. Muhammad got 78 in max and also 78 in English. Has he performed equally in both the subjects? Since the mark is equal, 78 in max and also 78 in English, how was his performance? Whether it's equal or not equal? How to address this issue? For this issue, we have to calculate the Z score. Z score is equal to the score got minus the mean of the scores and divided by standard deviation of the scores. If you calculate Z score for Muhammad for English and max, then we can compare whether both are equal or not. So we are going for it. Muhammad's max score 78 minus 70. The mean of the max score divided by standard deviation, it is 1. The English score 78 minus this is the mean of English score and standard deviation 20. Now we can see he is 1 standard deviation above the mean. The max score lies. The English score lies 0.25 standard deviation above the mean. So therefore, which one is better? The highest standing is 1 standard deviation. So therefore, this score is more than this, even though both are equal. The max he has got more than many people in mathematics. So you're understanding, huh? So this is 1 standard deviation. So 0.25 will be somewhere around here, 0.25. So this is max score and this is English score. So max score is more than the English. So another example, suppose an achievement score among college students are normally distributed with a mean of 500 and a standard deviation of 100. If a student scores 700, what would be her Z score? So what is the Z score for her? Z is equal to 700 minus 500 divided by 100. What is the value? 2. Z is equal to 2. So it's more. She got more. So Z score is more, therefore it is 2 standard deviation above the mean, hence the score is more. So then now this is the norms for checking whether our data undergoes, whether our data is normally distributed or not normally distributed. Here what we are calculating is Shapiro-Wilk statistic, and that statistic we call that as W. The value is W. And if the probability is more than or equal to 0.05, which means that the values are sampled from a population which follows normal distribution. If the probability value, is greater than or equal to 0.05, which means that our data follows normal distribution. The values are sampled from a population which follows normal distribution. If the p-value is less than 0.05, the values are not sampled from a population that follows a normal distribution. So that's what we see. I am showing the value. Later I will show the calculation through the demonstration. So we have the value as 0.959 and the probability is less than 0.005. This is 0.001, which is less than 0.005. Hence, the values are not sampled from a population that follows. That is the same. Our skewness value is still the same. Our kurtosis is also same. It's not following NPZ. Again, the final one is, this is called the skew plots. See, one Q means quantile, one Q is from the data, the other one is theoretical. So this diagonal is theoretical quantile. This is our data. If our data goes with the diagonal, then it is normally distributed. If it is not going, if it is going like S or bending, this is not a normal probability curve, because here this end and that end also it goes away the diagonal, therefore this does not follow. And you can see the histogram. We have left side skewness, negative skewness. So these are original data. We will check with the Jamovi. So these are my references. So now I will. So now we go to the Jamovi. Just I open. This is just open. Jamovi will take only CSV files. If you have Excel sheet, convert into CSV. It's easy. Open the Excel sheet, save as CSV. It will be saved. Now it can be taken in via Jamovi. So you'll open the data. So open. So it's in the folder. So I have this. This is original data. Knowledge, attitude, and practices in COVID-19. So almost 1,300 data we have. It's originally collected for research. So we have data which has been taken inside the Jamovi. So we go for descriptive statistics. So we go exploration. So this is no need to buy. This is available free. This Jamovi, therefore we can take. Again, there is a small correction. This total score is not. This total score is a scale. It's not. So I correct it. This is not a nominal data. Score is a continuous data. So therefore we go back. So we transfer the variables into this here, the one which we want to calculate. So total score of the COVID value. So we measured COVID knowledge, attitude, and practices through a scale. That is the total score. So now you have the statistics. Just click. That's all. You can get the values, modes. So the values are coming. It's being populated. Skewness. And see, from here only I took the data and I have shown in the PowerPoint. So the skewness value, standard error, those things I have taken, and we have divided and seen the value. So just you click it, whatever you want, you click it. Just that will be populated on the right hand side. So now we go for plots. Or normality also I can Shapiro with the value 0.959 and probability less than 0.001. That's all. Just by clicking we'll get there. Then again QQ plots. So you have here QQ plots. Just click it, you will get it. So again, histogram, just click it, you will get the histogram. So that's it.